Welcome to Calbeckistan, a place where anybody can learn math. I'm Mr. Calbeck. Today we're going to be doing episode 7 of our series on solving. We're going to be looking at some weird-looking fraction-y problems today. So if you've ever seen something that looks a little bit scary, go ahead and tune in today. So we've already looked at problems that look like this. Remember, when we're looking at fractions, we don't want to think of them as fractions. We want to think of them as division problems. Remember, this means division. So we already know how to do this. We would multiply both sides by 10 because, again, the opposite of dividing by 10 is multiplying by 10. Okay, remember, that's the opposite and the inverse. That means the same thing. So the question is, not this one, but what if I switch this around? What if I put the 10 on the top and the x on the bottom? Now suddenly we've got something that looks a lot different and a lot scarier because you can't divide by 10 because that's not what this is doing. Right? Remember, we always want to try to do the opposite of what's happening in any situation. And right here, what's really happening is this is being divided by x. Okay? So we got to figure out what the opposite of dividing by x is. I'm hoping you guys are shouting at your screen right now, multiplying by x, because that is the inverse operation, the opposite of dividing by x. So remember, x is just a number. So anything we do with numbers, we can do with x's. And we multiply both sides by 10 earlier. Now we can multiply both sides by x. So that's what I'm going to do. I'm going to multiply both sides by x. And just like when I did that in the other problems in the previous episodes, it cancels out, and what it does is instead of canceling out, it really just makes a big 1, because x divided by x equals 1. So your teachers might just cancel it out, but remember, every time you cancel something out, it makes a 1, and over here, I'm going to multiply by x. So that cancels out. That leaves me with 10 on this side, and now I have 5 times x, which is just 5x. Now this looks like a problem that we did much earlier in the series. We just need to do the opposite now of multiplying by 5. Multiplying by 5, that's dividing by 5. And you get 2. So all we need to do, if we have x in the denominator, is to multiply by x. All right, let's look at some other weird ones. Okay, here is another tough one. Right now we have a big ugly fraction, but again, remember, it's not a fraction, it's a division problem. Now the thing that's weird about this one is that there's more than one thing in your division problem. It's x plus 2, not just like an x or a 2 or something like that. But what I want you to remember here is that there's actually some secret parentheses there. I want you to go ahead and write those in every time you have a problem like this. Put those parentheses around there. And then realize that the entire side is being divided by 3. So the opposite of dividing by 3 is multiplying by 3. And since it's dividing the whole side, we can still use the golden rule to solve this. Okay, because the golden rule says that what you do to one side, you got to do to the other side. So dividing by 3, we're going to multiply by 3. And again, that cancels out into a big 1. Multiply by 3 over here, and you end up with x plus 2 equals 21. All right? Now we can solve this. X plus 2, all we have to do is subtract 2, because that's the opposite, and get x equals 19. Not bad, right? What happens if we put the thing like x plus 2, what if that's in the bottom? Now it gets even weirder. Okay, now this one is really, really challenging because now we have the denominator of our fraction again, the division part is x minus 3. This is looking pretty terrible. So let's start with what we did last time. We put parentheses around it. I want you to make sure that you always do that. Anytime there's more than one term in a fraction, go ahead and put parentheses around it because they are there. It's really important that we do that. And you'll see why here. And right now, we have 5 on one side, and over here it's being divided by x minus 3. Now this is going to look a little scary to you, but remember, the whole thing's being divided. We're going to do the opposite. The opposite of dividing by x minus 3 is to multiply by x minus 3. And even though it looks scary, anything divided by itself is 1. And we can multiply the other side times x minus 3 as well. So this totally cancels out, and all that's left is the 4 over 1 if you'd like. But again, you don't need to write that. It's a ninja 1, so I'm just going to leave it as 4. And over here we have 5 times x minus 3. But this looks like a problem that we did in the last episode. Lots of distributing, stuff on both sides. You know how to do this. Let's go ahead and finish it. We can distribute, put 5 into both of these, which is going to give me 5x minus 15. 4 is still over here. Again, we're working straight down the page. The opposite of subtracting 15 is adding 15. So we have 19 equals 5x. Now the opposite of multiplying by 5 is dividing by 5. So let's go ahead and do that. Those cancel out into a big 1. We have 19 over 5. Just leave it as 19 over 5. No teacher's going to get mad at you for that, and if they do, tell them to take it up with me. This is reduced, looks great. It's an excellent answer. Okay, one other thing that I want to bring to your attention. Some teachers are going to teach you to cross multiply. Go ahead and give me a thumbs up if you've ever heard a teacher say that. I actually really hate the term cross multiply because students, it's really easy to forget when to use it. So if you've heard your teacher say cross multiply as a shortcut, it's not really any shorter than remembering to do the opposite. And for me, doing the opposite makes a lot more sense because it connects to everything else we've done. So I'd really recommend that you not think about it as cross multiply. You don't ever have to use cross multiplication. All you need to do is think about doing the opposite. If it's dividing, multiply. If it's multiply, divide, and that's all you have to think about. Okay, I'm going to give you an example next where teachers like to use cross multiply, but all I think it does is makes things a little bit more confusing. All right, so here's a classic situation where some teachers will tell you to cross multiply. I don't think it's a great idea. Let's think about what the opposite is in each situation here. Okay, first thing though that I'm going to do is I'm going to put parentheses around here and around here because there's more than one term. Right, this 3 is being divided by x minus 1. The 6 is being divided by x plus 2. So let's do the opposite. On this side, I'm going to multiply by the opposite. The opposite is x minus 1 on the top. That's going to cancel this out over here, but I have to do it on the other side. X minus 1. Okay? Problem is, now I've got this ugly fraction over here. This is being divided by x plus 2, so let's do the opposite on this side as well. Okay, instead of dividing by x plus 2, we're going to multiply by x plus 2, and that's going to cancel out. But we have to do it to the other side as well. So this is getting pretty ugly right now. Let's go ahead and rewrite what we've got. These have canceled out over here, leaving me with 3 times x plus 2. These have canceled out over here, leaving me with 6 times x minus 1. And this is a problem that we know how to solve. X is on both sides of the equation, distribution, we can solve it. We'll distribute here, which gives me 3x plus 6. Again, distribution is multiplication, don't forget that. 6x minus 6 right here. All right, let's see if we can finish the problem. Now, remember we have x's on both sides, so I want to ask myself, which would make it easier? Would it make it easier to subtract the 3x or subtract the 6x? And I'm going to choose to subtract the 3x so that it stays positive. So I'm going to subtract 3x from both sides. We're almost done here. So we have 6 equals 6 minus 3x is 3x. Minus 6, we're almost done. I want to do the opposite of subtracting 6, which is to add 6. And we've got here, at the very end, 12 equals 3x. We can divide both sides by 3. And I'm going to go ahead and put it up here. 12 divided by 3 equals x, or 4 equals x. go. And that's all we have. Okay, now this looked really, really terrible at the beginning, but think about what the opposite is. If you're dividing by x minus 1, multiply by x plus 1. If you're dividing by x plus 2, multiply by x plus 2. You can actually solve just about any fraction problem like this. Think about it as division, do the opposite. You guys got this. We'll see you next time where we look at even more challenging problems.